Good morning, dear students, and once again, welcome back to our today's online class. We are studying about Boyle's Law, which states that at constant temperature, the volume of a given quantity of a dry gas is inversely proportional to its pressure. Or in other words, we can say that at constant temperature, the pressure of a given quantity of a dry gas is inversely proportional to its volume. And mathematically, we can represent Boyle's law as V inversely proportional to P. Inversely proportional, how do we write? 1 by P. Now, when we remove the proportionality sign, we get V equals to constant by P. And when we interchange, rearrange, we get the product of V, volume, into pressure, is constant. When we take the initial and the final conditions of pressure and volume, we find out that the product of initial pressure and initial volume is equal to the product of final pressure and final volume, which is constant. Therefore, we can write P1 into V1 is equal to P2 into V2, which will always be constant. Now, this relation is used to solve the numericals based on volume, pressure at constant temperature. So, these type of conditions are solved by using Boyle's law equation. So, let us once again try to solve some more numericals. Let's start with question number 1. The capacity of a cylinder is 4 cc and that of the other is 1 cc. So we have two cylinders, one having capacity 4 cc and the other having 1 cc. The pressure in the first cylinder is 560 millimeter mercury and that in the second cylinder is 1000 millimeter mercury. So these are the two initial conditions in the two cylinders. Both of these cylinders containing carbon dioxide are connected together by a tube fitted with a tap. Now, when the two cylinders are connected together, what will be their volume? Their volume will be 4 plus 1 because individually they have volume of 4 cc and 1 cc. So in order to find the total volume, we need to add their volume because the two cylinders are now being connected. What will be the final pressure in either cylinder on opening the tap if the temperature remains constant? So whenever temperature remains constant, we have to apply Boyle's law. So here the question is asking us to find the final pressure on cylinder 1 and on cylinder 2. So let us start solving this numerical one by one because we have to solve for cylinder 1 and cylinder 2. Now let us start with cylinder 1. Now let's see the conditions in the cylinder 1. Now initial volume of cylinder 1 is 4 cc, whereas final volume means after the two cylinders are connected together, the final volume of cylinder 1 becomes 4 plus 1 equals to 5 cc. The initial pressure in cylinder 1 is 560 mm, whereas now we have to find the final pressure in cylinder 1. Now according to Boyle's law, we have P1 into V1 equals to P2 into V2, which is a constant. Now we need P2, so we'll rearrange this to find P2 equals to P1 into V1 divided by V2. Now let's substitute the values of P1, V1 and V2 over here. So we get 560 into 4 divided by 5. Remember, final volume is 5. Now when we solve this, we get 448 millimeter mercury. So this is the final pressure in cylinder 1 when the two cylinders are connected. hence the required pressure in first cylinder is 448 millimeter of mercury. Now let's solve the same thing for cylinder 2. The initial conditions over here are volume. Initial volume is 1 cc. This is the initial volume in cylinder 2, 1 cc. Final volume, once they are connected, it becomes 5 cc. The initial pressure in cylinder 1 is 1000 millimeter of mercury, and now we have to find the final pressure in cylinder 2 when the two cylinders are connected. Again, here by Boyles law we have P1 into V1 equals to P2 into V2, which is a constant. Now we need to find P2, so we'll rearrange and we'll get this P2 equals to P1 into V1 divided by V2. Now we need to substitute the values of P1, V1 and V2, and we get 1000 into 1 divided by 5. So when we solve this, we get 200 millimeter of mercury. Therefore, the final pressure in second cylinder is 200 millimeter of mercury. So this is how we solve question based on more than one cylinder, and whenever these two cylinders are connected, their volume increases, and their increased volume will be sum of the individual volumes. Now let us again try to solve another question. Question number 2. A cylinder having a capacity of 750 ml contains oxygen gas at a pressure of 400 centimeter of mercury. What will be the pressure of oxygen gas when the container is connected to another container whose capacity is 450 ml? So here the things we need to note over here is the capacity of container. So capacity means volume. So a cylinder having a capacity of 750 ml, and remember, whatever is the volume of cylinder, same volume will be occupied by gas. So here nowhere in the question it is mentioned that the volume of the gas is so much. Here volume of cylinder is given, and that volume of cylinder will be the volume occupied by gas. So this is the initial volume of gas, and 400 centimeter of mercury is the initial pressure. Now the second part of the question says, what will be the pressure of oxygen gas? That means we need to find final pressure when the container is connected to another container whose capacity is 450 ml. So when one cylinder gets connected to another cylinder or another container, what will be the total volume? Sum of their individual capacities. So here final volume will be 750 plus 450 ml. Let's try to solve this. The given conditions are volume V1 750 ml, final volume V2, since they are connected, so 750 plus 450 will be equal to 1200 milliliter. Initial pressure is 400 centimeter of mercury. Now we need to find final pressure. So we know by Boyles law P1 into V1 is equal to P2 into V2. Now we need to find P2, so we'll rearrange this and we'll get P2 equals to P1 into V1 divided by V2. Now when we substitute their values, we get 400 into 750 divided by final volume is 1200, and when we solve this we get 250 centimeter of mercury. Therefore, when the two containers are connected to each other, the final pressure will be 250 centimeter of mercury. Please understand, you can always check whether your answer is correct or wrong. You just have to think that according to Boyle's law, when pressure increases, volume decreases, or vice versa. When volume increases, pressure decreases. So here what is happening? Volume is increasing. Therefore, what should happen to pressure? It should decrease. Therefore here, if initial pressure is 400, then your final pressure must be less than 400. If your final pressure comes more than 400, then your solution is wrong. Is that clear, boys? So always think smart. You can always cross-check your answers. So this is how we solve numericals when one container is connected to another container, or one volume, two volumes are mixed together, and we are asked to find final pressure. I hope I have made you clear about this type of numerical. Now, based on today's learning, there is an assignment for you, question number 1 and question number 2, and your answers are also provided so that you can verify your work by yourself. Until we meet next time, stay safe and do all things well.